Welcome back, guys. Today we'll be doing chapter 8. We will be creating and using methods. I'll be driving and navigating. Same applies to Bukudo. So over here, our objective after completing this lesson, we should be able to instantiate a class and call a method on the object, describe the purpose of a constructor method, create a method that takes arguments and returns a value, access a static method from a different class, use a static method of the integer class to convert a string into an integer, and overload a method. So the first topic we're going to be dealing with is using methods and constructors. So a basic form of a method, over here we've got our public void display. So the void keyword indicates that the method does not return a value. And then the empty parenthesis indicates that no arguments are passed to the method. And then, so this is the end of the display method, which are these curly brackets, the closing curly brackets. So inside of our method, we've got system dot out dot println, um, the shirt description and the color code and the shirt price. And then this is an example of a simple method that does not receive any argument or return a value. Okay, so we move over to calling a method from a different class. So we've got our public class, shopping cart, public static void main, string args. So over here, our, what is this? Our parenthesis, our argument, the argument that we have passed is actually string uh, args. So this is our argument string. And then we've got the shirt, my shirt equals to new shirt and the shirt dot display. So the method, the reference variable is my shirt, and then the dot operator, and then we've got our method, which is display, and then this is the output that we are going to get inside of um, our console. If we run this, we are basically going to get exactly what you see over there. We've got our shirt color code and our shirt price, and also our item description and the description required, which is a shirt, and also the description required as well, which is what we've been given at the bottom. And then so we move over to the caller and worker method. So in the previous example, the shopping cart class calls the display method on a shared object from within the main method. The main method is referred to as the calling method because it is invoking or calling another method to do some work. So then, when a calling method calls a worker method, the calling method stops execution until the worker method is done. After the worker method has completed, program flows returns to the point after the method invocation in the calling method. Then we move over to a constructor method. A constructor method is a special method that is invoked when we create an object instance. So it is called by using the new keyword, and its purpose is to instantiate an object of the class and store the reference in the reference variable. So over here we've got our shirt, my shirt equals to new. So this is our constructor method which we have called. So the constructor method is called over here because we have used the new keyword, and it has a unique nature, which is modifier, class name, and then the parenthesis. So constructor is invoked using the new keyword. Its job is to instantiate and whatnot, as we have already explained. And then we move over to writing and calling a constructor. So over here we have created our constructor using the new keyword over here that we can see. So our constructor here, we drop it down to line 8 where we say public. I will definitely move to that. I think it's over here. Yeah. So we say public shirt. We've got our description and what we have in our console and the color code and the price inside of our constructor. And then we've got our method over here. And then we've also got our fields, which have got our public string, description, the color code, character color code, and the double price. And then, so the constructor is the first method called when an object is instantiated. Its purpose is primarily to set default values. And then we move over to calling a method in the same class. So we've got so this is by saying display parentheses. We have got this is we've called it normally, but then we've called using the this keyword, which is this dot display. Then so calling a method in the same class is very straightforward. We can simply use the method name using a reference. This is the same as when accessing a field. You can simply use the field name. However, if we have local variables with similar names and we want to make it obvious that our code is accessing a field or method of the current object, we can use the this key word with dot notation. It's used as a reference to the current object. And the example above explained, like gave us an idea of how that takes place. So I'm going to hand over to Recruiter who's going to take over. Wait, yes, from take over from method arguments and return values.
So I'll be continuing from where Sharon stopped. So now we are dealing with method arguments and parameters. So they said an argument is a value that is passed during a method call. There we can see an argument. They showed the argument there, denominator. It's our argument. And then they also described a parameter as a variable defined in the method declaration. So a parameter would look like this int x double y. So those are our two parameters. And then so our argument will, I think, include a number and a called method, I think. Yeah. And then in this one, the parameters will be x or y, with both numbers actually. Okay. And then when we move on to method parameters examples. Let me see. Uh, so we have a method that may have any number or any type of parameter. So as we can see there, our parameter here will be int x or x divided by 2.0. So it's just different. They come in different shapes, like in different. So I think parameters will come in form of letters, yes, and then it can also include numbers. And then method return types. Variables can have values of many different types like string, double, long, boolean character, shared, and method calls can also return values of many different types, same thing. And then how to make a method return a value. We declare the method to be non-void return type. We use the key return so that it can notify that is returning. And then they said variables may have values of different types, including primitive datas, types, objects, and array. And then they said constructors are special; they cannot have a return type or even a void. And then still examples. So and then we have method return animation. So this one we we have the public void main, and then we have the numbers one, two, and then we have the results. So we adding the for us to get the results, we just add the value of one and two, and then it will print the results for us. Or we can just have the sum by multiplying value 1 and 2, and then it's another example where we take the sum of these numbers and then we multiply these numbers with the sum of it, and then we get the number, we get the results, the answer. And then we have passing arguments and returning values, and then they gave us the structure that value pass from caller method to worker method, and then we also have the value received, and then we have the value returned. So the example would look like this. We have the customer service, and then we have the string message, would you like to hear about, and then it's a string, would you like to hear about or whatever specialties in your area. And then we have the if statement, if is new customer, then the email should be sent with this message here. And then we have another example where we just returning the boolean, and so these are the codes without the methods. So we have shared 1, shared 2, until 3, and then we just have the description, the color code, and the price for each. And then we'll choose if we want to print 1 or 2, and then we'll see the results. We'll have all the description, the color, and the price of whatever number of the shade that we're gonna choose. And you will tell me where to stop, Sean. And
Um,
I'm supposed to stop now? Not yet. And then we have the advantages of using methods. Methods are reusable. They make programs shorter and more readable. They make development and maintenance quicker. They allow separate objects to communicate and to distribute the work performed by the program. I think, yeah, I think I'll,
yeah, over there.
yeah, okay.
Okay, so right now we're moving over to using static methods and variables. So over here, the static modifier is applied to a method or variable. It means the method or variable belongs to the class and is shared by all objects of that class. Is not unique to an object instance, can be accessed without instantiating the class. And then comparison, a static variable is is shared by all objects in the class, and an instance variable is unique to an individual object. So then we'll move over to the examples. So setting the size for a new item. So here we've got our public class for our item sizes, and then we've got our static final string m small, which is for men's small, and static final string m mid, which is for men's medium. So here we are passing the static m mid variable to the set size method by saying item dot set size item sizes dot m mid, and then over here we've also passed the size argument um, for the males mediums. And then so in the example above, this is like a more detailed explanation. The class item size contains two static variables of type string, m small and m mid. These are initialized, which is over here, and these are initialized to a description of a particular min size. These values can be used without instantiating item sizes, which is over here. And then the code snippet shown in the middle of the slide shows an item object being instantiated, and then the set size method of the item object is invoked, passing in the item sizes dot mid mmid as an argument. The code example at the bottom of the slideshow shows the item classes. It contains a string field, a size. The set size method requires a string parameter to set the size field over here. And then we move over to creating and accessing static members. To create a static variable or method, static string m small, and then static void set m small string description. And then to access a static variable or method, we have from another class item sizes dot m small, item sizes dot m set m small, means small, yes. And then from within the class, it will be set m small, means small. So, okay, that's where the difference is that if it's from another class, then we have to put item sizes um, dot method. And then if it's from within the class, we do not have to use the item sizes dot method. And then when to use static methods of field. So performing the operation on an individual object or associating the variable with a specific object type is not important. Accessing the variable or method before instantiating an object is important. The method or variable does not logically belong to an object, but basically belongs to a utility class, such as the math class included in the Java API, and then uses using constant values such as math.py also is a time when to use um, the static method or fields. Yeah. And then here are some rules about static fields and methods. So instance methods can access static methods or fields, and then static methods cannot access instance methods or fields because um, here we've got an example of a public class and then public class for the item. And then we've got on line 6 our static integer get ID. So whose item ID? So what basically is happening here is that we are basically not allowed to access the instance method or field using the static method, because the item ID is an instance variable. That means that each item object has its own presumptually unique item ID. In this example, its value is set in the constructor. And then also another reason why is because the get ID method is static, so it can be invoked even if there is no item object created. So yeah, that was the reason why. And then we move over to static fields and methods versus instance fields and methods. So above we show a more complex example for an item class that has an instance variable, instance item ID, and a static variable, static item ID. So here we have our public class item that has got our item 1 equals to new item, which has got a static item ID equals to 6 as instance item ID, which is equals to 3 and is not correct. It's like not a correct method or format. And then show items ID is also not a like the correct format, but the one at the bottom. So number 1 and 4 have got the right format for us to get the results. And then we move over to object instance referenced by item 1, and then 5 and 6 as well is another instance of items, which is basically a better way and the correct way of how to do it. And then we move over to static methods and variables in the Java API. So examples are some functionalities of the math class, exponential, logarithm, oh my word, trigonometric, random access to common mathematical constants such as the value pi, and also some functionalities of the system class, retrieving environment variables, access to the standard input and output streams, exiting the current program system.exit methods. So these are all static methods and variables in the Java API. Then we move over to examining static variables in the GDK libraries. So this is basically our GDK library. So this is system is a class in Java.language. Okay, and then out is a static field of the system and contains is an object reference to a print stream object. Okay, and then we move over to using static variables and methods system.out println. So basically, this is an explanation of how system.println is actually used inside Java and how it actually allows us to be able to see our results inside of the console after we run it. So then, yeah, then we move over to more static field and methods in the Java API. We've got our Boolean, which is a Boolean type, and our double, which contains a single field of a type double, and an integer, which contains a single field of the type int. And then they also provide utility methods to work with the data. So there's different types. And then we move over to understanding how arguments are passed to a method, and I'll hand over to Rakudo who will take it from there.
So now we are moving on to understanding how arguments are passed to a method. So passing an object reference is similar to a house address when it is passed. The object itself is not passed. The method can access the object using the reference. The method can act upon the object. And then they give us an example here that we paint the house, so it's gonna work as the um, uh, they showed painting the house, and then we pay, we sign, and then it's done here. And then um, what if there's a new object? So this is suppose that the owner of the house moves to another house before the job is finished. Will the painter be able to find the owner's new house in order to paint? The object reference my house has changed to a point to a new house, but the notation in the painter's notebook still refers to the old house. If the owner expects the new house to be painted, he or she will be disappointed. So a shopping cart code example, we have the shopping cart, and then we have the shed, which is the new reference type, or the shed here after my shed. So and then so and then this will be the result. And then they said when the method is invoked, the value of the arguments are used to initialize the parameter variables before the body of the method is executed. This is true for both primitive types and references. This is true, not if. This is true for both primitive types and references. And then we have the passing by value here. So we're passing the method by value. There we have shed, my shed, new shed, and then we want to change the shed color to be like we were doing with the house painting and everything. So we are changing here the color code. Um, so and then we are reassigning the reference. So when we reassign the reference, we have the shopping cart, and then we have the main thing, and then we have shed my shed, which will print out this string here, and then we have change shed color. We want to change the color of this original shed to this, and then it will change. And then we have this method here, change shed color. And then uh, we are passing by. Okay, we already did this. Yeah, so I'll hand over to Sharon. I think I'm done on my part here. Sharon.
Okay, so we'll be doing the last topic will be which will be overloading a method. So method overloading. So overloaded methods have the same name, have different signatures, the number of a parameter, the type of the parameter, the order of the parameter, and then may have different functionality or similar functionalities, and also are widely used in the foundation classes. So in Java programming language, a class can contain several methods that have the same name but different arguments. So the method signature is different. This concept is called method overloading, just as you can distinguish between two students named Jim and in the same class by calling them Jim in the green shirt and Jim in the beeper. You can distinguish between two methods by their name and arguments. So here we're going to be using a method overloader. So we've got our calculator class, final class actually, and our public static integer sum integer number. So we've got our method type, which is the integer, and the method signature, which has got integer number one and integer number two. And over here we've also got like another example for the sum as well, the float sum, and also different types of the method signatures. So then we move over to using method overloading again. So here we've got we used the integer and the float as well. So the code example in the slide has a main method that invokes each of the previous sum methods of the calculator class. And then we move over to method overloading and the Java API. So these are the methods and the uses of the methods. So if we had time, we'd go through that, but I don't think it's that necessary. So many methods in the Java API are overloaded, including the system.out.println methods. The table in the slideshow shows four variations of the print line method. So here we move over to the exercises, which we basically do for homework, and the quiz, which for this quiz the answer is C. And then for a summary in this lesson, we learned that how to add an argument to a method, instantiate a class and call a method, overload a method, work with static methods and variables, convert data values using integer, double, boolean, object types. So thank you so much, guys. We'll see you in the next video.